presentation, which is focusing on what is the Marie Curie Innovative Training Networks. This is basically a kind of a fellowship or a scholarship which is of interest to you during your graduation or after your graduation, if you are interested in research. So before I get into this, a short background about myself. I'm basically from India. I then studied in the Delft University in Netherlands, and then worked in UK for a couple of 2 years before I joined TTI to contribute in the Marie Curie Fellowship Network. So, first off, what I'm trying to say here is, this is what I will try to put across to you. I'll tell you what is the Marie Curie action, what it is, how it is, and why it is. And then I'll say my view of obtaining the fellowship, what I did to get it, so that it would benefit you. And then I'll go through some mobile communication trends which are happening now, which is more project focused. I'll tell you about our project network, and then the focus that we are doing in TTI. TTI is a company just blocks across this building. You might have come across. So, so that's the thing. Then perhaps if you have any questions in the last about the Marie Curie Fellowship as such, I can share it with you guys as well. So, what's the Marie Curie Fellowship? So, this is basically, it supports enthusiastic researchers. For example, now you're studying, you find some topics to be very interesting, and you find some topics to be very appealing to yourself. So you can take that, and at all stages of your career, you can apply and pursue it, and irrespective of your nationality in different countries. That's the catch about Marie Curie. That's the good thing about Marie Curie. And you can work across all disciplines, not only engineering, not only telecommunication or computer science or anything in particular, but anything as such. And you are eligible for funding because funding is there for all the disciplines in Marie Curie usually. So researchers are handsomely compensated. You get your living, mobility, and travel allowances all well balanced. So it's a very good fellowship. Now, how do you get into this fellowship? Now it's usually advertised on prominent websites like Nature. On your access and other details of duration and type, nature of work can be extracted from those websites. And there is also this MCFA, which is the Marie Curie Fellows Association, which gives you information about these kinds of fellowships. And the good thing about this is that, for example, if you are interested in a particular field of science and technology, that particular field of science and technology is focused upon in the Marie Curie grants or fellowships. So it's not that you will be going into some esoteric field and trying to do something on your own. That's not like that. It's like it's something that's trendy, that's happening, that's always there. So it's good in that fashion. So, and why? My biggest thing, why would you want to take up a Marie Curie fellowship? Is that it gives you exposure to a lot of new and innovative technologies that are at the forefront. Really, they are at the forefront. So, and a fantastic way to collaborate and learn from experts from all over the world. For example, now I have options to travel to different parts of Europe, and also to interact with different people, different ideas. It's just like an agglomeration of different ideas and stuff. It's a fantastic way to do that. And there are frequent training sessions that will equip researchers with useful skills, not only in technical side but also in your career. For example, you will get training on how to do different things such as present, or to get yourself into a different option career or something like that. And of course, many more, as you will discover yourself once you are into the Marie Curie Fellowship. Well, this is something, what I think is it should be the way to obtain the Marie Curie Fellowship. If this appeals to you, then you should be, if you ask me, you should be doing this to get into that. So what I try to say is, first find an area of interest that is what actually drives you, what actually motivates you. Get into that, and then try to look up for the MSCA fellowships advertised in the EURAX's webpage. It's a webpage sponsored by the EC Commission, European Commission, and then apply on it. And if you are successful with you apply with your what's your basic idea of what you want to do in the project. Actually, you give a brief project proposal of what is it that you want to try to do. Once it's accepted by the panel members, they will ask you for an interview. And if you're not here, let's say you're applying to a place in UK, or you're applying to a place in France or Germany, you don't have to travel. It's usually using Skype. So the screening is done on Skype as well. So that's nice. That's the way that's nowadays done. And then, of course, you can then enjoy the benefits to learn and contribute to being a Marie Curie Fellowship holder. Definitely. You can always, it's really, I would say yes, it is. Now, that was about the Marie Curie Fellowship and all the things. Just to give you a brief overview of what it is like, what the fellowship is, what kind of work you do. I don't get into the details of what I do here, but I just give you a brief overview of what things are like and what we work on at TTI. So this is the global communication trends. You know, I don't have to say that. Mobiles everywhere nowadays. So everybody is on the mobiles. The data rates are springing up. So I have some Cisco VNI indexes. So this is what is happening. You can see from the past 10 years, there is a 4,000-fold increase in the mobile traffic. And for the past 15 years, 400 million-fold increase in the mobile traffic. So we need more speeds. We need faster video downloads. We need faster buffering. There should be no buffering. Everything should go on very well. So for this, it's the physics. It's to drive in more higher speeds, get higher networks, which are more capable of handling higher speeds and data. So for this, we need something called we are going with generations. You will have come across this 1G, 2G, 3G, 4G, 5G. It's all on your mobiles. So now we are into what is called as the 5G now. We're researching on that. It's going to come in the next few years. We are targeting at 2020, around 2020. So basically, it's offering several gigabits per second. You know, it's not megabits or it's not in kilobits per second. It's in gigabits per second. It's going to be a huge bandwidth, and that's what we're targeting on. So it's basically interesting because it allows us to have videos real time, have holograms possibly in the future to be shown in front of you in real time. So that's something that can be there. This is the network that I'm actually on, the 5Gwireless network. It's spread all over Europe in 6 different countries. It basically has 15 ESRs for working on this project, and there is a collaboration between all of these individual countries and the institutes that you see there. So we have 3 in Spain, TTI, 5Gwireless, and UPC. So this gives you a cross-sectoral understanding of the work from different perspectives. Allows you to learn things in a different way. You know, more eyes see more. So always that's the thing. The project focus at TTI. This is what I focus on in my particular project. What we are trying to do is the one that you see here is what is called the massive MIMO. It's something that happens to increase the data rates. And this is the single RF MIMO, which is basically a function of that. And these are the prototypes which are manufactured by some companies. And we are trying to make something on these lines, which would allow us to increase the data rates of the 5G networks. That's basically the idea of the project. So I think. Well, that's all I have to say. If you have any questions, I would be happy to answer. Yeah.
Why do you think the government in Spain actually doesn't care about the 5G connection? Why do you think that the Spanish government doesn't do, and the other governments like German or French, they in their politician campaigns, Angela Merkel, we got the 5G here, and we have to do it.
It's a very good question, actually. You know, this 5G is itself in a kind of a cloud definition. It's not completely defined yet. We don't have a standard. Like, for example, for the 2G, 3G, you have standards. You have international telecommunication union standards. You have FCC standards. You have different standards which are defining what exactly like. 5G is more of a kind of. It's in the infancy. You can say it's in infancy. It's developing now. People don't know what it is like. Nobody knows how it is going to be in the next 5 years. So it's a bit of a confusion. A lot of players are already into it. Some are getting into it. So I don't know why it shouldn't be in Spain, but I think because we are working on that, it already shows that they are interested in it. So that's the question. Have I answered your question?
Yes. And when we passed the 3G for the 4G here in Spain, we got, I don't know if you the TTT, the digital television service, and it works at 600 MHz.
600?
Like the 4G goes at the same frequency. And the Spanish government don't know why. I tried that you can explain it for me. Why they push the television at this frequency if they already know that the 4G becomes right there?
4G, well, I cannot speak for the government, but the thing is, I understand your question. The technical part of it is that the thing is 600 megahertz is where the television broadcast is usually, and that's what is called the white space, TV white space. In US, there is a lot of research going on TV white space to tap that area of research. That's possibly because why they want to get into the lower frequency again, because it's low bandwidth, but a lot of data rate can be handled in that frequency, low frequencies. Because of that, they are trying to have it in the 600 megahertz range, as you said. That is one possible thing. And another possible thing is there are some gaps in the spectrum, even in the TV spectrum. There are some gaps which you can use, and that is why it is called TV white space. That's one of